Heavy materials, rugged environments, often dusty or wet, full of vibration. Equipment reliability, accuracy of weight essential. To run your operation efficiently, to keep your bottom line looking right. Virtually any industry that moves materials on a conveyor belt that requires its products to be accurately and reliably weighed can benefit from the Ramsey Series 20B belt scale. The 1020B single idler belt scale system is designed and manufactured to provide high accuracy and repeatability in the most rugged and harsh environments. Following the procedures and recommendations presented here and in the Series 1020B instruction manual will ensure that you will benefit from our years of experience in the belt scale industry. Assuming you have selected good scale hardware, the application and installation of your belt conveyor scale becomes all important in determining how accurately your belt conveyor scale system will perform. In applying belt conveyor scales, one must always consider external influences originating from the material handling system and belt conveyor. Regardless of stated accuracies, these two factors will determine the long-term and short-term accuracy you may expect. The following guidelines should be adhered to in order to optimize belt scale performance and weighing accuracy. Begin by reviewing the information pertaining to the scale location criteria outlined in the system's manual. A partial listing of the required guidelines are: 1. Install the scale system on a rigid conveyor. Deflection should be minimized to 24 thousandths between adjacent idlers. If not, additional bracing is required. 2. The scale should not be located closer than 3 idler spaces from feeders, hoppers, and skirt boards. 3. The scale must not be placed in concave or convex curves. 4. The scale should not be installed where conveyor speed and slope causes material slippage to occur. 5. Locate the scale where it has maximum protection from the elements. 6. The scale conveyor should not be attached to or have vibrating devices installed on it. Using this information, determine the best location for the scale carriage. Check for joints or seams in the conveyor structure that may cause deflection or movement in the immediate scale area. Fish plate and weld to ensure a stable platform. Make sure the conveyor is level and not twisted at either end of the scale area. The scale area will be aligned approximately 1/4 inch above the conveyor belt line. To determine this level, a string line can be pulled down the top side of the belt, approximately 30 feet in either direction, or from the feed point to approximately 8 idlers beyond the scale. After applying tension to your reference line, you find a gap between the line and belt carcass. Add 1/4 inch to this distance to determine the amount of shimmying required for setting up the end reference idlers. Where little or no gap exists, the scale area need only be plus or minus 2 idlers. For each additional space of 1/4 inch, 1 additional scale idler should be added to provide a level, uniform plane. These hand tools will help in proceeding with the installation. In addition, a welder and cutting torch will be required. Use proper safety equipment and procedures whenever working with mechanical equipment. For ease in equipment installation and alignment, elevate or remove the conveyor belting from the belt scale area. Remove all idlers between the -2 and +2 from the conveyor section where the weigh bridge will be installed. One of the idlers removed may be modified and used as the weigh idler. New mounting feet are supplied bolted to the scale carriage. Since it is not recommended to weld on the inside portion of the scale carriage, they are removed so they can be properly dimensioned and attached to the idler frame. Refer to the weigh idler modification drawing in your manual for the exact mounting dimensions. It is important that the new feet are mounted square and perpendicular to the idler frame. After welding in place, the old feet are removed and the frame notched out to provide clearance between it and the conveyor stringer. To aid in the alignment, locate and center punch the carry roll on all idlers from -2 to +2. Dimensionally locate the -2 and +2 idlers using a known reference point or the diagonal method. They should be 4 times the idler spacing noted on your particular installation drawing and be perpendicular to the belt travel. At the same time, shim these idlers 1/4 inch above the belt line as determined earlier. These end idlers will be used as a reference height for the rest of the scale area. Insert the weighbridge assembly into the conveyor gallery. Shipping brackets may be removed at this time. Mount and dimensionally align the weigh idler so it is the proper distance from the pivots or trunnions. The weighbridge may also be used as a reference. The carriage may now be positioned so the weigh idler is midway between the +2 and -2 idlers. With the holes marked, slide the carriage out of the way to drill mounted holes in all 4 corners. Fasten the weighbridge to the conveyor gallery. Set up reference lines across the center carry roll and on each wing idler to be used for alignment and shimmying. A 10 to 40 pound test non-filament line or 20,000th 8th gauge piano wire is recommended. Sufficient weight or tension must be applied to prevent any sag in the line. At this point, check for clearance between reference lines and the carry rolls. If the lines are touching, additional shims must be inserted under the -2 and +2 idlers. With the lines in place, position and shim the remaining idlers to maintain a true and level plane for the belt to pass through, minimizing any belt tension effects. To shim and align the +1 idler, measure the gap for the required shims. Install shims under each idler foot. The idler may have to be positioned to the left or right to align wing rolls. Measure and adjust spacing to provide the exact distance between the weight idler and the +1 idler on both the left and right side. Check the final alignment with idler mounting bolts tightened. If correct, the reference wire should be plus or minus 1/32 of an inch. Repeat the procedure for the -1 idler. The last idler to align is the weigh idler. After shimmying to the proper height, relocate idler by using the -1 idler as the reference. This completes the mechanical installation of the weigh bridge and scale service idlers. Prior to removing string lines, check that all scale area idlers are at the proper spacing within 1/32 of an inch. All the carry and trough rolls are shimmed to within 1/32 of an inch of the reference height of the -2 and +2 idlers. The speed sensor is to be driven by a non-driving pulley such as a conveyor tail pulley. Direction of rotation is not important since the sensor is unidirectional. A coupler, restraint arm and spring are provided for a direct free-floating mount. To avoid stress on the sensor shaft, rigid mounts are not recommended. Installation begins by drilling and tapping a 5/8 inch national coarse thread hole approximately 1 inch into the pulley shaft. The hole should be centered to minimize eccentric run. The coupling may then be threaded in and tightened. If rotation is such that it is the reverse of the threads, a lock nut or an application of Loctite may be required. To complete the installation, a mechanical stop and spring mount will be required. The spring should only be tensioned approximately 1/2 inch to keep the restraint arm in place. The speed sensor shaft is secured by the 4 set screws on the coupler. Flatlands are milled on the sensor shaft for contact surface and will prevent slippage from occurring. An alternate coupler is provided for stub shafts. Refer to the manual for this and other mounting methods. This concludes the mechanical installation procedure for the Series 20B belt scale.
The Ramsey Sea Level is a microprocessor-based continuous level indicator for liquids or bulk material solids. It's designed to provide low-cost and reliable level indication for most vessels and bins supported by metal members. The sea level consists of the GZ1 strain sensor and associated J-box and a microprocessor-based electronics package. In many operations, the volume of material in a container needs to be known either for inventory monitoring or process control purposes. However, it's often difficult to determine the material level without visually inspecting the contents in the container. As this can be difficult or impossible to do at times, other means of level detection must be employed. There are many different types of level detecting systems available in the marketplace. However, no single system can be used on all applications. The sea level is ideally suited for those applications where, 1, the container is